When we look at the night sky, we are looking back in time. The light from distant stars carries ancient history. But what if we could look back further? Beyond the birth of our stars, beyond the Big Bang itself. What if the oldest picture we have of our universe contains not just its own baby photos, but the ghostly echoes of a cosmos that died before ours was born? Today, we're exploring the ultimate cosmic detective story, the search for our universe's ancestors. Our story begins with a single, profound image, the cosmic microwave background, or CMB. This is the afterglow of the Big Bang, captured when the universe was a mere infant, just 380,000 years old. It's the foundational blueprint for everything we see, the galaxies, the stars, us. For decades, satellites like WMAP and Planck have mapped this fossilized light in exquisite detail. Scientists expected to see a chaotic, random pattern of hot and cold spots, the seeds of future structure. And they did. But as they looked closer, some researchers, led by one of the greatest living physicists, began to see something else. Faint yet strangely perfect concentric circles, ring-like structures that stood out against the random noise. According to our standard models of cosmic inflation, the idea of a violent, explosive birth, these large, coherent patterns simply shouldn't exist. They are like finding a perfect geometric carving on a prehistoric bone, an artifact that seems intelligently designed, buried in primordial chaos. The man who saw these circles not as a flaw, but as a message is Sir Roger Penrose, a Nobel laureate who helped prove black holes are real. And he proposes a theory so radical it redefines reality itself, conformal cyclic cosmology, or CCC. Penrose's idea is elegantly simple and utterly mind-bending. He says our universe is not the first and only. It is one aeon in an endless, infinite chain. There was no singular creation, only an eternal cycle of death and rebirth. Here's the staggering part of his vision. Imagine the far, far future of our universe. Trillions upon trillions of years from now, all stars have burned out. All black holes have slowly evaporated, releasing their energy via Hawking radiation. All that remains is a vast, empty, silent sea of featureless light. And Penrose proposes that in this state, the very concepts of big and small, hot and cold, lose all meaning. Mathematics shows that this infinitely large, cold, empty end is identical to an infinitely small, hot, dense beginning. The end of one universe becomes seamlessly the Big Bang of the next, the ultimate cosmic recycling. But a beautiful theory needs proof. And Penrose made a spectacular prediction. If a previous universe existed, it too had supermassive black holes. At the end of its time, as those black holes finally evaporated, they would have unleashed titanic spherical bursts of energy, their final death cries. Now, imagine the next universe being born from the ashes of the old. That colossal energy from a dying black hole wouldn't just vanish. Think of it like pressing your finger into a balloon. The dent on one side is visible on the other. In the same way, Penrose argues, the shock wave from a black hole's death in the previous aeon would have left a permanent, circular dent in the newborn fabric of our universe. He calls these imprints Hawking points. And he claims the strange circles in the CMB are precisely these Hawking points. We are not just looking at the seeds of our own galaxies. We are looking at cosmic tombstones, the fossilized scars of monstrous black holes that lived and died in a universe that existed an eternity before our own. This is where the story splits. The scientific community did not embrace this idea with open arms. For most cosmologists, extraordinary claims require extraordinary evidence, and they believe Penrose's evidence is fundamentally flawed. Their argument is about statistics and human nature. When you stare at a complex, noisy pattern, like the static on an old TV, your brain is wired to find shapes, faces, animals, patterns. This is called apophenia. Scientists argue that's what's happening here. In a dataset as vast as the CMB, you are guaranteed to find some seemingly perfect circles purely by random chance. Teams have reanalyzed the Planck satellite data with more rigorous statistical filters. In 2018, a major study concluded, we find no statistically significant evidence for these anomalous circles. The patterns are consistent with the random fluctuations predicted by the standard model of inflation. For them, the case is closed. It's a beautiful story, but it's just that, a story. We are seeing patterns in the cosmic static. So who is right? The visionary Nobel laureate seeing a glimpse of infinity, or the meticulous statisticians guarding the gates of established science? The truth is, we don't know yet, and that's precisely why this debate is so important. It's not just about circles on a map. It's a battle for the origin of everything. It forces us to ask, are we alone in our singular, fleeting existence? Or are we part of an immortal, cyclic saga where the end is always a new beginning? If Penrose is even partially correct, it would be the most profound discovery in human history. We would have a birth certificate for our cosmos, and on it, listed under parent, would be another long-dead universe. Our cosmic family tree would extend back into eternity. Right now, it remains the boldest of all ideas, unproven, contested, but dazzling in its ambition. It reminds us that science at its frontier is not just about answering questions, but about learning how to ask better, more profound ones. As new telescopes probe deeper into the heavens, they won't just be searching for new planets or galaxies. They'll be searching for our deepest past, listening for the faint, lingering echo of a world before our world. The ultimate question remains, are we the first universe? Or are we simply the heirs to a legacy of cosmic cycles, stretching back forever? What do you think? Is our universe an only child? Or does it have infinite siblings in the corridors of time? Let us know in the comments below. And if you want to explore more mysteries at the edge of science, subscribe for more. Thanks for watching.